you chat with an AI, it feels like magic, right? But what is actually going on inside that black box? Today, we're going to peel back that curtain. We're going to uncover the surprisingly simple idea at its core, the absolutely mind-boggling scale of its training, and the one key breakthrough that really makes it all possible. Let's get into it. So, here's how we're going to break it all down. First, we'll start with the simple prediction machine that's at the heart of everything. Then we'll get into the epic, truly epic scale of its training. After that, we'll see how it goes from just a text generator to a genuinely helpful assistant. And finally, we'll pull back the curtain on the transformer technology that powers this whole revolution. All right, section 1, the prediction machine. And you're probably thinking this is going to be super complex, right? But the core idea is actually way simpler than you'd imagine. In fact, it's something you kind of do every day without thinking about it. Okay, so it really all comes down to one big question. When you type something into a chatbot, how does it actually write what comes back? It's not thinking in the human sense. It's doing something much, much more straightforward. Okay, think of it like this. Imagine you have a torn movie script. You give the AI the first few lines. Its only job, its entire job, is to guess the single most likely word that comes next. That's it. Once it makes a guess, you just tack that word onto the end of the script and feed the whole thing right back in. Then it guesses the next word. You just keep doing that word after word, and boom, suddenly you've got a whole paragraph. It's just one simple loop repeated over and over. And that right there is what a large language model is. Seriously, forget all the hype for a second. At its absolute core, an LLM is just a very, very sophisticated mathematical function designed to do one thing. For any chunk of text you give it, it predicts the most probable next word. But here's the really clever part. The model doesn't just spit out one single word with 100% certainty. Instead, it generates a ranked list of probabilities for all the possible words that could come next. By sometimes picking the second or third most likely word, it introduces a little bit of randomness, a little bit of creativity. And that's the reason you can ask the same question twice and get two totally different, but still natural-sounding answers. Okay, so that brings us to our second big topic, training at an epic scale. This is where we really get into the large part of large language model. And believe me, the numbers here are just wow. So how does the model actually learn to make these predictions? Well, you can imagine its brain is made up of billions of tiny little dials, or what the engineers call parameters. Now, the most important thing to get here is that no human goes in and sets these dials. They start out totally random. Like the model's first attempts at speaking, just complete nonsense. The magic happens in the training process, where the model slowly teaches itself how to tune all those billions of dials. So how does it learn? Well, it reads. It reads a lot. And when I say a lot, I mean, check this out. For a human to read all the text that was used to train GPT-3, reading nonstop, 24/7, no breaks, it would take you 2,600 years. And that's an old model. And if you thought that was wild, the amount of pure computation is even more mind-boggling. Let's say you had a supercomputer that could perform 1 billion operations every single second. To finish the training for just one of these models, it would still take that computer over 100 million years. I mean, the scale is it's almost impossible to wrap your head around. So, what's all that computing power actually doing? It's running a really simple feedback loop, trillions of times. Here's how it works. The model gets shown a sentence from its training data that the last word is hidden. It has to guess the missing word. Then, it gets to see the right answer. If it was wrong, a clever algorithm makes tiny, microscopic adjustments to those billions of dials, just nudging them in a direction that would have made the right answer a little bit more likely. Now, just imagine doing that trillions of times. Okay, so at this point, we have a model that is an absolutely incredible text prediction machine. But here's the thing. Just being able to predict the next word from the internet doesn't make it a helpful or safe assistant, right? That takes another super important step. This is how you turn it from a raw text generator into a true assistant. This whole process really happens in two main stages. First, you've got pre-training. That's the phase where the model basically just inhales a giant chunk of the internet. Books, articles, websites to learn grammar, facts, and reasoning. But then comes the really critical alignment phase, often called reinforcement learning with human feedback, or RLHF for short. This is where actual humans step in. They rank and score the AI's responses, basically giving it a thumbs up or thumbs down to fine-tune it to be more helpful, harmless, and aligned with what we actually want. So we've got the simple core idea, and we've got the massive, epic scale. But what's the piece of tech that actually makes processing all this data even possible? What's the engine under the hood? Well, that brings us to our last section, the transformer breakthrough. You see, up until a game-changing paper in 2017, language models had a huge problem, a major bottleneck. They had to read text just like we do, one word at a time, from left to right in order. And this was incredibly slow and put a hard ceiling on how big and powerful these models could ever get. And then, along came the transformer architecture. Its genius was that instead of reading word by word, it was designed to process all the words in a piece of text at the exact same time, in parallel. This was a total game changer because it meant it could take full advantage of modern computer chips, like the GPUs in gaming computers, which are built to do tons of things at once. Suddenly, the doors to massive, massive scale were blown wide open. So inside a transformer, there are really two core ideas at play. The first is a brilliant mechanism called attention. It basically lets every single word in a sentence talk to every other word all at the same time. This is how it figures out context, like knowing the word bank means a financial institution in money bank, but means the side of a river in riverbank. The second part is the feed-forward network, which you can just think of as a huge memory bank. It provides the enormous brainpower needed to store all the complex patterns about language it learns during training. And this brings us to what might be the most mind-blowing takeaway of all. The people who build these models, they create the architecture and the training process, but they don't explicitly program any of its amazing skills. The ability to reason or write code or summarize a document, these are all emergent phenomena. They just appear kind of out of nowhere, from the simple task of predicting the next word, just repeated at an absolutely insane scale. And that, of course, leaves us with one last really fascinating question. If all of today's incredible abilities weren't programmed in, but just emerged from the process, what happens when we scale it up even more? What other new abilities are just waiting to emerge from these machines? Really, what comes next?